This is my third electricity video, and it's about resistance. Now, the current through a component, the current that flows through a component depends on the voltage that we put across it, and it depends on a proper component that we call its resistance. And you can think of it as how hard it is for a current to flow through something, how much it resists the flow of current. Okay, we can use a circuit like this to investigate what we call the characteristics of a component. The characteristic of a component is basically a graph of voltage against current. We change the voltage across the component and we look at what happens to the current that flows through it. We measure the voltage with a voltmeter, we measure the current with an ammeter, and we plot a graph. Now, this is a characteristic for a filament lamp, a light bulb which has a filament in it. Now, looking at the graph, voltage against current, clearly it's not a straight line. The relationship is not linear. Now, resistance has the symbol R, and it is measured in ohms, named after a Scottish guy called George Ohm. And to find the resistance of a component, we divide the voltage across it by the current through it, hopefully a very familiar equation, R equals V over I. So the voltage across it divided by the current through it. Nothing to do with the gradient, it's just R equals V over I. So looking at this graph, there's three different points on the graph, A, B and C. Use data from the graph to find the resistance of the bulb at A, B and C. Do that yourself and the answer is, okay, so at point A 38.5 ohms, at point B 71.4 ohms, and at point C 103.4 ohms. So what's happening is that as we increase the voltage across the bulb, the current through it gets bigger and its resistance gets bigger. Why is this? And it is because, well, the metal has a higher resistance because it's harder for the electrons to flow through it. Why? Because at higher temperatures, because the wire gets hot, at higher temperatures, the metal ions are vibrating more vigorously. So there's more collisions. The electrons find it harder to get through the gaps between them. There are more collisions. And as the electrons collide into the metal ions, they gain energy, so they vibrate more, so the resistance of the wire increases. Remember that the resistance of metals increases with temperature, and be able to explain why. Now, a resistor is a component that is designed to have a certain resistance. For example, this is a 100 ohm resistor. It is supposed to have a fixed resistance of 100 ohms. This is the characteristic for a fixed resistance, and a VI characteristic will just be a straight line. We say that it obeys Ohm's law. Ohm's law says that voltage is proportional to current at constant temperature, so a resistor obeys Ohm's law. Notice that the gradient for a 100 ohm resistor will be twice as much as for a 50 ohm resistor. This is another component we need to know the characteristic for, and it's a diode. A diode only lets current flow one way. Basically, in the direction of the arrow, it has a very small resistance. We say it is forward biased. And in the other direction, it has a very high resistance. It is reverse biased. Looking at the graph of V against I, for negative voltages, there is no current. For positive voltages, you do need a little voltage to get it going, which is usually about 0.6 volts, but then it has a fixed resistance and it behaves like a resistor. We usually always put a resistor in series with it to limit the current, to protect it. An LED is a light emitting diode. You must be able to recognize these graphs. You must be able to sketch them. These are the characteristics you need to know. The three graphs at the top are the VI characteristics that we have discussed, voltage against current. You should be able to recognize them and explain their shape. Notice that I've included positive and negative voltages. A negative voltage is basically you put the component in the other way round. The three graphs at the bottom are I against V. It's the same data, we've just swapped the axes, so they are IV characteristics.